Good day, grade 11s. Welcome to Lerondi Academy. Today, we'll be looking at Newton's laws, and here we'll be looking at an object that is on an inclined plane. The question that I have deals with two objects that have been combined together by a light inextensible string. What we need to remember there is what is the tension force that will be present. This is the question. Right. So in this question, we'll be dealing with with Newton's laws. Very important. Right. Before we waste any time, let's start with this question. Now, the scenario reads as follows. They say, we have a light inextensible string connects two objects of mass 6 kg and 3 kg respectively. What does that mean? In that order, right? So you see in a diagram, we start with 6 kg and we have 3 kg. That's why they say respectively, which means in that order. They are pulled up an inclined plane. It is important to understand first the direction of the motion of the system. Is it going up the inclined plane or down the inclined plane? So this friend of ours, the system, beautiful system, is going up the inclined plane. And this plane, they say it makes an angle of 30 degrees with the horizontal. With a force of magnitude F. They did not give us the magnitude F. So meaning that we will be required to calculate this. Now they say ignore the mass of the string. Most of the time we ignore the mass of the string because if we don't, now it's going to even affect the acceleration of the system. I.e., if we take into account the mass of the string, it means the total mass in the system will increase. And what will happen to the acceleration? The acceleration has to decrease. Remember, acceleration and mass are what they are inversely proportional from your Newton's second law. That the acceleration is directly proportional to the net force and inversely proportional to the mass of the system. Now, we are given the coefficient of kinetic friction for the 3 kg block and the 6 kg block is 0,1 and 0,2 respectively. Right. Before we go further with this question, I want to show you the exam technique that I require every student to know. So this is our inclined plane, forms an angle of 30 degrees. We have 6 kg block there, and then there we have a 3 kg block. Right. We have force that is applied there of unknown magnitude. Are we happy? Right. Because they've given us the coefficient of kinetic frictions for each block, the examiner is being silent. Examiner is being silent to say that me telling you that this are the coefficients of kinetic frictions between the block and the surface. This means that these two objects, they do experience frictional force, i.e. this is a rough inclined plane. So it means there will be frictional forces. Right. Before you go and attempt any question, firstly, identify for yourself all the forces that are acting on this object as these objects are moving up the inclined plane. Two simple forces, it's your normal force. Both this object will have normal force. Why? Because they are in contact with the surface. Secondly, because they've told us the coefficient of kinetic friction, in the 6 kg block, we're going to have the kinetic friction there, frictional force, because this object is going up the inclined plane, the frictional force needs to act in the opposite direction. Now, in the 3 kg block, same thing, we're going to have your frictional force. Then now here, on the string, we're going to have tension, but it will act in opposite direction. Remember that from class. Right, so the tension here is going to act down the inclined plane here is going to act up the inclined plane. Right, then now, our friend, gravitational force. Gravitational force now has a tendency of what? Of changing direction when an object is on an inclined plane. It divides itself into two components, being the Fg perpendicular, which is the perpendicular component of the gravitational force, and Fg parallel, being the parallel component. Right, if you're in my class, there's a story that I always tell learners how this guy behaves and why does it strip itself into two components. But for the purpose of this video, we are focusing on question 2 on Newton's laws. Right. Then this will be your gravitational force, Fg, changing direction, forming an angle there with the incline of 30 degrees. And now here we have your Fg perpendicular, and Fg perpendicular is always in equal magnitude with your normal force. Right. And then we have your Fg parallel, always acts down the inclined plane. So on the 3 kg block, same thing, we have your Fg there, and then we have your Fg perpendicular, and then we have your Fg parallel, which is acting down the inclined plane, and then here you have your 30 degrees. Someone would say, ask me, why are you doing all of this? I'm preparing myself to say I need to know all the forces that are acting in these two objects. Secondly, if the question wants me to draw a free body diagram, I'm only going to replace these two blocks with what? With a dot, and then copy and paste all these forces on my free body diagram. Right. Now, it's a two-body system. It being a two-body system, this is a technique that I require every learner to use when answering a two-body system. Right. This is what you do. You divide this into two. We have two blocks. You have the 3 kg block, and then you have the 6 kg block. We're going to deal with them separately. You collect data for the 3 kg block and data for the 6 kg block. They told us that the coefficient of kinetic friction on the 3 kg block, it's 0.1. And on the 6 kg block, it's 0.6. Right. Then, with this coefficient of kinetic frictions, what does this mean? We're going to use this, guys, to determine our frictional force. Remember, Fk is equals to mu k times normal force. Fk is equals to mu k times normal force. Your Fk, it's equals to mu k times, but we just said your normal force in an inclined plane is always equals to your Fg perpendicular, will be mg times cos theta. Same thing here, Fk is equals to mu k mg cos theta. Now, we can determine the Fk being equals to 0.1 is 3.98 cos 30 degrees. Fk 0.6 and sorry, is it 0.6? I read it wrong, it's 0.2. Then your mass is 6.98. Then you have cos 30 degrees. Then your Fk, you'll see your Fk on the 3 kg block will be equals to, take your calculator, 0.1, then you have 3, you have 9.8, then you have cos of 30 degrees, then you get 2.55 newtons. It's 2.55 newtons. That is your frictional force on the 3 kg block. And your frictional force on the 6 kg block, it's now 0.2 times what? 6, 9.8, and then we have cos of 30 degrees, and then you get your 10.18. 10.18 newtons. Right. I haven't read any information. Right. I'm just read only the given data. Now I say, what can I use first with this given data before I even rush to do what? To answer the question. Right, thank you. Now we can go and read the question. 2.1, the question states that, 2.1, the question states that, let me zoom in. Sorry, don't zoom in there. Right. Now, the question states that we need to state Newton's second law of motion in words. We state Newton's second law of motion in 2 words. Guys, it is important to know your definitions. 2 marks can increase your chances of getting a distinction. Remember, we don't want this 30%, right? We want to get a distinction so that we can be doctors, entrepreneurs, accountants, right? So we are required to state Newton's second law in words. So we say, when a net force acts on an object, the object will accelerate in the direction of the net force. Full stop. When a net force acts on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional to the net force. What does that mean? It means when the net force increases, acceleration increases. When the net force decreases, acceleration also decreases. And inversely proportional to the mass of the object. Two marks. Right. When a net force acts on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional to the net force. When net force increases, acceleration increases. When net force decreases, acceleration decreases. And inversely proportional to the mass of the object. If the mass of the object increases, what happens to what? To the acceleration decreases. But remember, during the investigation, we are told that it's 3 things here. We have the net force. Remember the Newton's second law equation. F net is equals to ma. If we're studying or investigating the relationship between net force and acceleration, we need to keep the mass of the object constant. Right. Same applies if we are looking at the relationship between the mass and the acceleration. Your net force needs to be what? Need to be constant, i.e. the force that we are applying on that object. Right. We're done with question 2. Now we go to question 2.2. How will the coefficient of kinetic friction be affected if the angle between the incline and the horizontal increases? So the answer here, guys, remains the same. Please look at my second video. I will explain very well why am I saying the answer here remains the same. You will see why I am saying that. If the angle of inclination increases, what happens to the what? What will happen to the coefficient of kinetic friction? Right. Now we go to 2.3. 2.3 states that now we need to draw. 2.3, we draw a labeled free body diagram indicating all the forces acting on the 6 kg object as it moves up the inclined plane. It is important. We are focusing where? On the 6 kg block. And remember earlier on, what I have done is that I have identified all the forces that are acting on my block. So I take my 6 kg block, there it is. Right? Then, remember it's a free body. free body diagram. Then I replace my object with a dot. Now I copy the forces that are acting on the 6 kg block. I have indicated that there is frictional force. I have indicated that there is tension force. Are we happy? I've indicated that there is Fg, which changes direction. It divides itself into two components, Fg parallel and Fg perpendicular. And lastly, I indicate my normal force. These are all the forces at 30 degrees. These are all the forces that are acting on the 6 kg block. Are we happy with that? Then you get your 5 marks. This question, is it 5 marks? No, it's 4 marks. You get a 4 marks. It's 1 mark for each force. But with this one, the Fg, we give you 1 mark. We give you, even though you've shown all the components, we give you 1 mark for that Fg and its components. Right. Now, we go to question number 2.4. It says calculate 2.4.1. The tension in the string if the system accelerates up the inclined plane at 4 meters per second squared. Important. Accelerates up the inclined plane at 4 meters per second. Remember, we said in this topic, two-body system, the acceleration will be the same for both of the objects. Meaning that both objects, the 6 kg block and the 3 kg block, will be accelerating up the inclined plane at an acceleration of how much? Of 4 meters per second squared. The tension between these two objects, the tension in the string, will be the same in magnitude on both objects, but acting in opposite direction. We said the tension on the 3 kg block will act down the inclined plane, and on the 6 kg block, it acts up the inclined plane. So now, two things. We have the 6 kg block and the 3 kg block. The question now becomes on these two blocks, we need to determine the tension. On these two blocks, the 3 kg and the 6 kg. Right. The 3 kg block is going to have two unknowns. We don't know the tension and we don't know the force that was applied to pull the system up the inclined plane. Right. On the 6 kg block, we don't know only the tension. We can use the 6 kg block to determine the tension. The tension that we get on the 6 kg block will be the same tension that is on the 3 kg block, but in opposite direction. So to do that, we use Newton's second law. F net is equals to ma. This F net is equals to ma. It's the equation that we use to help us determine the unknown acceleration, the unknown force acting on the object. Now, step number 1. On the 6 kg block, remember we did what? We draw a free body diagram. Now, when we use F net is equals to ma, we need to determine the forces that are acting on the object, so that those forces will include them in our what? In our F net. Right. Now, when you go here, we say we have these forces: tension, normal force, frictional force, and the components of the gravitational force. First question, which forces are we going to include in our F net? That will depend on the direction, that will depend on the motion of the object. Is it going up the inclined plane, right? Or is it going in this direction? So we have two types of forces. You have the forces that are going in this direction and the forces that are going vertically. Are we happy with that one? Now, first thing, we say our system is going up the inclined plane. We need to include only the forces that are acting along, or rather I can say parallel to the inclined plane. Any force that is acting perpendicular to the inclined plane, we disregard it, which means I'm going to disregard the normal force. I'm going to disregard also the Fg perpendicular. The only force that are going to be shown in my F net is your tension because it acts parallel to the inclined plane, my frictional force, and my FG parallel. Because even FG parallel is acting parallel to the inclined plane. Very important. Right. Now, so we have tension plus, remember it's net force, it's the sum of all the forces that are acting in the object. But here, I have disregarded normal force and FG perpendicular. Right. Tension plus frictional force plus FG parallel. It's equals to your MA. That's your first step, identifying those forces. Second step, the signs are important. A force is a vector quantity that's both magnitude and direction. Now, your tension force is in the same direction as the motion of the object. The motion of the object, i.e. up the inclined plane, takes preference. We take it as what? As positive, meaning that any force that is going up the inclined plane will be what? Will be positive. Any force that is acting down the inclined plane will be negative. So my tension is going to be positive, my frictional force becomes negative, even my FG parallel becomes negative, and this is equals to MA. The last step now is to filter in the magnitudes. Do I know tension? No. Do I know frictional force? Yes, I did calculate it for myself there of the 6 kg block. It's how much? It's 10,18 minus FG parallel is mg sine theta. Just open a bracket there a bit. Then that will be 9,8 sine 30 degrees because of space. It's equals to 6 open bracket 4. Right. So T minus, I take my calculator. Open bracket 10,18 close bracket, right? Because remember it's what? It's minus minus. So minus minus means you must add, right? Plus open bracket, I have 6, 9,8, then I say sine 30, then you get 39,58. 39,58. I get 39,58. This is 39,58. It's equals to 6 times 4. You get your 24. Then your tension will be equals to 24 plus 39,58. Then your tension, it's equals to 1 plus 24. You get 63,58 newtons. 58 newtons. Right. Now, we go to question 2.4.2. They want now the magnitude F of F if the system moves up the inclined plane at constant velocity. Now, constant velocity means that the acceleration is equals to 0. Constant velocity, remember grade 11s. A is equals to Vf minus Vi divided by change in time. Constant velocity means what? Means that the velocity does not change. The final velocity is the same as the initial velocity. If we have to give this velocities hypothetical values, let's say final velocity is 1, even the initial velocity is going to be 1 divided by change in time. 1 minus 1 is 0 divided by change in time. This gives you 0 acceleration. So constant velocity always means that acceleration is equals to 0. Right. If acceleration is equals to 0, you'll see that even F net is equals to MA will be equals to 0 because the acceleration is equals to 0. Now, acceleration has changed. It's no longer 4 meters per second. It's now what? It's now 0. It means now we need to determine the new tension. Tension needs to be determined, the new tension. Now, determining the new tension, Determining the new tension, same technique applies. Now, listen. We have the 3 kg block. We have the 6 kg block. We do F net is equals to MA. F net is equals to MA. Are we happy? Right. We know acceleration is equals to 0. So F net, this side will be equals to 0. Even this side, F net will be equals to 0. Now, F net, all the forces that are acting on the 3 kg block. Our 3 kg block, remember we had also identified all the forces that are acting on the 3 kg block, right? We're going to have the force that is unknown, that is your unknown force. Your force that is not unknown, then you say plus, you're going to have your tension, plus your frictional force, plus your Fg parallel. It's equals to 0. Same applies on the 6 kg block. We're going to have the tension, plus your frictional force, plus your Fg parallel, it's equals to 0. Now, choosing the sign, you'll see your F is in the same direction as the motion of the object, will be positive. Then the rest are acting in the opposite direction, will be negative. Negative frictional force, negative Fg parallel is equals to 0. On the 6 kg block, tension is positive. The rest become what? Negative Fg parallel. It's equals to 0. Right. Now, it's equals to 0. Now, listen. The magnitude, we don't know the frictional force. Minus, we don't know the tension. Minus. Now, the frictional force, we calculated it to be 2,55 minus your mg now, right? So your mg is the one that is what? That is unknown. Then your mg becomes, it's known. Your mg, remember you said mg sine theta, that is your Fg parallel, right? We're going to have your 9,8 sine 30 degrees. This will be equals to 0. Then I'm going to have my F minus T. Now, minus, because it's negative and negative, I'm going to have 2,55 plus, open bracket, 3, close bracket, and then we have 9,8 sine 30 degrees. We get how much? 17,25. We have 17,25. It's equals to 0. We leave this like this. We can't go anywhere. You don't start by solving simultaneously. We need to see what's happening on that side. Because only on that side you'll see the only unknown on the 6 kg block. It's what? It's your tension. We don't have the tension. We do have 10,18 was our frictional force. We can determine our Fg parallel as 9,8 sine 30 degrees is equals to 0. We punch our calculator to determine the sum here. We have 10,18 plus, open brackets, 6, 9,8 sine 30 degrees. Then we get 39,58 is equals to 0. Then your tension now, important. The tension is equals to 39,58 newtons. What did I say? I say both the objects in a two-body system, they have equal what? Magnitude with respect to tension, but this tension acts in opposite direction. The tension here is negative, is acting in down the inclined plane. Here it's positive. So they are acting in different directions, but the magnitude, so we say, needs to be the same. So it means I take this tension, then I'll substitute on the 3 kg block, because both of this object need to have the same what? The same tension. Then you have my F, then minus, now I substitute 39,58 minus 17,25, it's equals to 0. Now I can find my F. It's minus, I say 39,58 plus 17,25. Then I get 56,83. 56,83 is equals to 0. Now you will see that my force it's equals to 56,83 newtons. They wanted the magnitude, I give them the magnitude. If they wanted only the force and they did not specify the magnitude, I must also indicate the direction. The direction of this force will be up the incline plane. Right, so thank you so much for watching this video. Please follow those rules on Newton's second laws, on Newton's laws, two-body system. F net is equals to ma. Then we are done for the session. Thank you so much. We will see you.